The following program is brought to you by Copeland Corporation.
Hi, my name is Glenn Hannigan. I'd like to help you understand some of the common causes of compressor failures. When looking into this subject, you have to start with one very interesting fact. Industry records clearly show that replacement compressors, whether they are new or remanufactured, fail at a rate many times greater than compressors going into new systems. This clearly demonstrates that there is often a problem with the system itself. This problem has caused the original compressor to fail and will probably cause the replacement to fail as well. So how do you tell if your failure was caused by a system problem? The answer is inside the failed compressor. You have to open up the compressor and look for the various clues that can show you the true problem. Many failures end with the motor burnout, misleading some technicians into thinking that the root problem was electrical. This just isn't the case. Inspections show that the problem usually starts somewhere else and gets steadily worse until it causes the motor to fail. The blame goes to the motor. The true problem remains. There are 5 main causes of compressor failure: flooded starts, refrigerant floodback, slugging, overheating, and loss of oil. We're going to look at overheating in this tape and learn what overheating is, what causes it, and what we can do to prevent this problem. Let's watch.
Overheating problems occur when the oil in a system is heated to the point where it loses its ability to lubricate. If the heat is high enough, the oil breaks down chemically. Now, the generation of heat is a natural result of compressor operation. Motor heat, friction, and the heat of compression are all considered when designing a compressor. So if the compressor is kept within design limits, no harm results. But extended periods of overheating will bring premature failure not only to the individual compressor, but to the entire refrigeration system as well. Oil and refrigerant break down in severe overheating and create carbon and acids, which can cause harm throughout the entire system. The most visible clue of severe overheating in a compressor is carbonized oil on the discharge reeds and the discharge side of the valve plate. This valve plate has been discolored due to oil breakdown. The same tremendous heating effect that caused this carbonization also weakens discharge reeds so that they leak or break. Another clue shows up as fine iron particles in the oil. Since the hottest point in the compressor is at the discharge port, heat from this area conducts through the cylinder walls. The high cylinder wall temperature will cause the oil to lose its ability to support a load, and the result is worn pistons, rings, and cylinder walls. This wear causes 2 major problems affecting compressor life. First, the fine iron particles left from this wear remain in the compressor oil and can clog the compressor oil pump screen, which further decreases the available oil for cooling and lubrication of the bearing surfaces. And secondly, these fine iron particles may coat the end turns of the motor and cause an insulating effect or physically cut the winding, causing a spot burn of the motor. Another visible sign of overheating damage is caused by worn rings and pistons, allowing gas to blow by the piston and pressurize the crankcase. Even with a crankcase ventilating system, the excess crankcase pressure resulting from blow-by causes the oil return check valve to close. This prevents oil from returning to the crankcase from the motor compartment. The visual indication of this is that the oil level drops during the run cycle until the compressor cycles off on the oil safety control. When the compressor stops, the oil level will suddenly reappear in the crankcase sight glass. Finding any of these visual signs indicates that substantial damage has already occurred and should signal you to make system changes to avoid a repeat of the problem. Overheating of compressors is caused by 4 system problems: high compression ratios, high return gas temperatures, inadequate compressor motor cooling, and selecting the wrong refrigerant. The first cause of overheating, high compression ratios, is a direct result of operating a compressor at too low a suction pressure, too high a discharge pressure, or a combination of both. For long life, any compressor should be run at the lowest possible compression ratio. In low temperature applications, overheating is a predominant reason for failure. Suction pressure represents an area of system operation that a service technician has to take some positive action to control. Watch for undersized evaporators or oversized compressors. Check for plug dryers to be sure a solid column of liquid can enter the thermostatic expansion valve. Set the valve to a minimum practical evaporator superheat recommended by the fixture manufacturer. Keep the pressure drop in the suction line to a minimum and still maintain sufficient velocity for proper oil return. You can reduce discharge temperature faster by raising suction pressure than by any other means. The other cause of high compression ratios is high discharge pressures. This can result from a variety of system problems, all of which end in the condenser not being able to reject the heat from the refrigerant. Such things as a blocked condenser, undersized discharge line, lack of sufficient condenser air or water circulation, inoperative fan motors, overcharge, non-condensables such as air in the system or having an undersized condenser can also be blamed. In addition to high compression ratios being a cause of compressor overheating, suction lines which pass through hot spaces can cause excessive superheat on refrigerant-cooled compressors. Proper insulation of all suction lines outside of the refrigerated space will help prevent this problem. The amount of air movement across the compressor is also critical. Air-cooled compressors require at least 650 feet per minute air velocity across the body whenever the compressor is running. If there are no condenser fans to provide this airflow, auxiliary cooling fans must be used. Refrigerant-cooled compressors operating at a suction pressure corresponding to a saturated temperature of 0 degrees or below require at least 1,000 feet per minute of air velocity across the heads. Finally, you should consider the refrigerants you use and their effect on discharge temperature. The use of R12 refrigerant usually presents no problem. R22 is a very poor refrigerant to use for low temperature applications, and it is marginal for medium temperature applications below 10 degrees Fahrenheit. While R502 is easier to cope with, it is not immune to problems if operated with excessively low suction pressure or high return gas temperature. Now that we know some of the causes of overheating and some of the signs of damage, how do you check for the problem before it causes damage? The answer is easy. Oil thins out at 310 to 320 degrees Fahrenheit, causing ring and cylinder wall wear. It breaks down completely at 350 degrees. To find out if you are in danger of overheating, you simply find the temperature of the oil on the cylinder walls. Since you cannot measure these temperatures inside the compressor, you must take your measurement after it leaves the compressor. The temperature will be 50 to 75 degrees less than the internal temperature when measured about 6 inches from the discharge service valve on the discharge line. That makes it simple. A measurement of 275 degrees on the discharge line means that you have an internal temperature of 50 to 75 degrees hotter or 325 to 350 degrees and represents certain failure. Likewise, 250 degrees on the discharge line represents a danger level, and 225 degrees represents the maximum temperature allowed for safe operation. Because suction pressure has the greatest effect on discharge temperature, remember that the system needs to be checked at the lowest load condition. This may mean using a temperature recorder or a heat-sensitive tape. As a last resort to save a compressor when all other changes are impossible or impractical, consider the application of a de-superheating expansion valve. This valve injects liquid refrigerant into the suction line and must be installed at least 2 elbows away from the compressor. The liquid flashes and cools the suction gas to a temperature that keeps the compressor from overheating. De-superheating valves are specifically designed for this application. See your Copeland wholesaler for the proper valve. Remember, liquid injection consumes a little compressor capacity, but this is preferable to losing compressors periodically. To review, overheating causes premature wear on cylinder walls and pistons by breaking down the oil's ability to lubricate. This leads to a series of related problems such as clogged oil screens and iron particles throughout your oil. Signs such as carbonization, heat discoloration, and piston blow-by into the crankcase are sure signs of overheating damage. Overheating is caused by three system problems. They are high compression ratios, inadequate compressor motor cooling, and high return gas temperatures. Furthermore, the application of the compressor and the refrigerant used should be looked at when correcting or avoiding an overheating situation. The surest way to check for overheating is to measure the discharge line temperature about 6 inches from the discharge service valve. It will read about 50 to 75 degrees Fahrenheit less than the temperature of the cylinders. The rule is, at 275 degrees, you are experiencing overheating damage, and the situation should be corrected immediately. At 250 degrees, you are in the danger zone and also need to make immediate changes. At 225 degrees or less, you are okay. Remember, if all other methods fail, you can place a desuperheating valve on the suction line at least 2 elbows away from the compressor to inject liquid refrigerant into the system. This will cool the intake gas temperatures and help avoid overheating. Overheating is a destructive and multifaceted problem that has to be dealt with quickly. Following the advice on this tape will help you avoid this problem.
We have seen overheating can cause several problems, often detected by carbonization, discoloration, oil screens clogged with iron particles, crankcase pressures elevated by cylinder blow-by, loss of capacity, and many other signs of premature wear. You can check for overheating by measuring the discharge line temperature about 6 inches from the discharge service valve. This will tell you if you have overheating, and then you can deal with the system problem causing it. After making sure that all other remedies have been performed, you can add a desuperheating valve to the suction line to cool the incoming gas. Remember, replacing a failed compressor in a system with a problem will often gain you nothing more than another failed compressor. Study your entire system rather than looking at the individual components. Improper diagnosis and improper corrections will create a whole new set of problems. Proper diagnosis and proper corrections will make a world of difference. On behalf of all the people at Copeland Corporation, I thank you for your attention. For additional information on other causes of compressor failures, ask to see the other Copeland tapes in this series.